everybody. And so I'm just setting up so we can take a look at our next video. Okay, so we're working our way through Unit 2 of Chapter 3 and 4 with quadratic functions. The section we're looking at now is such an important one. It's section 4.2, where we're solving by factoring, solving quadratic functions or quadratic equations by factoring. The objective is simple, but the process requires a lot of practice. So please don't go quickly through this and make sure you do every single homework question. I've actually taken this video and divided it into 3 parts, and we're going to be doing it over 3 days in class, but this video is one. So the vocabulary, make sure you know the difference between factors and factoring so that you can keep it all straight in your head. So we've been exploring how to find the x-intercepts of a quadratic function. We looked first of all at drawing graphs and then simply picking out the x-intercepts so we could use them. But of course, the problem with graphing is that we don't always have a graphing calculator. And so one of the realities is if we can actually get the quadratic equation or function into the factored form, like this one, then we can easily pick out what makes this y a 0. It's when it's an r and an s. So it's so easy to see what those x-intercepts are or the zeros are. But the question really is, how do we solve this algebraically? How do we rearrange the standard form to look like the factored form? How do we take something in the standard version and turn it into this one? And really, this all boils down to something that we call factoring. At least that's what we try first when we're getting ready to do this algebraically. So this is a review. You learned this in grade 10, and then we did it again in math 11. So now we're doing it again. And so we're going to review it really quickly. We're going to add a few things that are a little harder, a little different, and we just want to get you to the place where you're comfortable with factoring. So how do we factor a quadratic equation in standard form? So there are a number of skills we're going to need to review so that you will be able to handle anything that I throw at you. One of the first things that I ask you to watch for is be sure that you keep looking for the greatest common factors. You always ask yourself, is there something that I can factor out of this equation to start with? And we're going to be, meanwhile, reviewing factoring a trinomial, actually taking a 3-termed equation like the following and trying to figure out how to factor. So notice the question, determine the roots of the quadratic equation. This is a quadratic equation, so they're saying look for the roots. Okay, so we look at it and breeze through it. We see that there is not a common factor, so we're not going to worry about that. So we're going to go straight into our trinomial steps that we used. And what we do is we take the a value, which is 1, multiply it by the c value, which is negative 21. And that means that we're going to be looking for 2 numbers that multiply to be negative 21 and add to be the b term, which is 4. Those 2 numbers that satisfy those things are positive 7 and negative 3. Now, we learned in Math 11 that as long as this coefficient is a 1, we can take these numbers and go directly to our factors and write them x plus 7, x minus 3, and we get a value for our actual roots of x is equal to negative 7 and x is equal to 3. So we go straight to our answers in this one because the coefficient in front of the x squared was simply 1. We'll take a look at the process where we pull it apart. We call it decomposition in a few minutes. And certainly, if you're feeling uncertain about these questions, just go ahead and use that same process of decomposition for every question until you start to feel confident about it. Next one. We have a question in front of us. We ask ourselves, is there a common factor? Sure enough, there is. And so we're going to pull out that 2, first of all. And so we're going to pull it out to the front, and we divide it out of each one of these. And so we get x squared minus x minus 6. Okay, and then we go about trying to find the numbers that will kind of set this up perfectly. What multiplies to be 1 times negative 6? So negative 6 and adds to be negative 1. That is a negative 3 and a 2. And so because the coefficient in front of this guy is a 1, I can use these numbers to go directly to the answers of my factors. So I write x minus 3 and x plus 2. And then I have to ask myself, okay, what makes these guys a 0? If x minus 3 is equal to 0, that means x is a 3. And if x plus 2 equals 0, that means x is a negative 2. So I have 2 roots of my quadratic equation. Next one, I take a look at it and think, oh my goodness, knot in my stomach. There's a fraction. But don't despair. We can get rid of it so easily. We take a look at this fraction and think, you know what? If I just took everything and multiplied it by a 4, I'd get rid of it. This guy would disappear. It'd be x squared. Then this would be minus 4 minus 12 equal to 0. So I look for two numbers, 1 times negative 12. So multiply to be negative 12 and add to be negative 4. My two numbers are negative 6 and 2. I go directly to my answers, and I see that I haven't written down what my answers are. Mrs. Darash, you've made a boo-boo there. So anyway, x minus 6 equal to 0 would mean that x is a 6. X plus 2 equals 0, that is also negative 2. So the two roots are 6 and negative 2. And by the way, the two factors of this quadratic are x minus 6 and x plus 2. Okay, and we're just going on. We're just keeping on practicing this one. If you take a look at it, we do have a coefficient of 2, but we can't divide it out of everything. We're stuck with it. So here we're going to be reviewing the longer process of decomposition, and we're going to be factoring by grouping. So let's look at it. We look for two numbers that multiply to be 2 times negative 5. So multiply to be negative 10 and add to be the middle term negative 9. Turns out that's a negative 10 and a 1. So I take those numbers and I rewrite my middle term. I pull it apart, so to speak. I call it negative 10x and plus 1. And then I factor by grouping. I take the first two and I pull out a common factor of 2x, leaves me with x minus 5. And then I take the last two and I realize, well, there's nothing I can factor, but it is a positive 1. And then it leaves me with x minus 1. Both of this is one number plus another, and they both have a common factor of x minus 5. So I have a factor of x minus 5, and the leftovers are 2x plus 1 equal to a 0. I find that my roots are x equals 5 or negative 1 over 2. Okay, one more sort of regular, sort of everyday one, and it's this one. Now, this is a little hard to see in the beginning, but I'm asking you, what is this pattern? If you look really closely, you're missing the x term. You have a perfect square minus another perfect square. We call this the difference of squares. And so factoring this one's easy. We take the square root of this, the square root of that, and we subtract it and add it. Gives me two answers. My x is equal to 0.8 over 3 plus or minus. And I need to fix this. I'm not allowed to leave a decimal, so it's 8 over 30 and reduce it 4 over 13. Keep in mind that with a question like this one, you could actually solve it algebraically as well. You could move the 0.64 over, divide by the 9, take the square root, and as long as you remember that your answer could be positive and negative, then you'll get the same answer. Okay, we call that the difference of squares. Now, this is the new stuff. What happens when the equations look a little more complicated? What about when it looks like this? When you first look at this, you think, oh my goodness, this is really complicated. Am I going to have to expand this and simplify it? Well, take a look. You've got x plus 2 squared. You don't have to worry so much about the 12. And then you've got x plus 2 by itself. And then you've got numbers without it. Do you see how this pattern is basically a quadratic, where instead of x squared, you have x plus 2 squared? Well, the key to this one then is, since it looks like a quadratic, I'm going to just let my x plus 2 equal something. I called it b in this one, and I rewrote it. So this would be the same as 12b squared minus 24b plus 9. That allowed me to take this and actually solve it. Now, I first got it rid of, I divided everybody by a 3, and then I looked for two numbers that multiplied to be 12 and added to be negative 8, and they were negative 6 and negative 2. And then I factored by grouping, found that my factors were the following. Now, what I need to realize is this could be a 0, this could be a 0, but what I need to remember is what I said back here, that b is really x plus 2. So I'm going to use this guy and make him equal to 0, but I put in, instead of the b, that it was x plus 2. See that? And then this one, I put it in, that's x plus 2, and then I solve for x. And I find out that x is equal to, it does look like that's I think it's 1/2, and then negative 3 over 2. So a very interesting question. Go over this slowly, pause the video, take a look at it, and you're really going to have to practice it. Here's another one. Now this one is random again, but it is the difference of perfect squares. And so I'm going to take it and I'm going to find the square root of this, which is 390 plus 1. And the square root of this one, 2, s minus 2. and I'm going to add them. This is subtracting first and then add them. And then I simply just clean it up. I just multiply everything out, bring all the numbers that are together. So, it doesn't look all that beautiful, but at least we've noticed that it was the difference of squares and we've factored it. Okay. So what about some real life applications then? Well, take a look at this. This is called dock jumping. It's a sport, actually, and so people actually train their dogs to do this. And you can see that this lovely dog is creating a parabola. So, the path of a Jack Russell Terrier on a particular jump can be approximated by the following quadratic function, where h is the height. Now, I don't have h there. Whoops. So h needs to be right here. It's the height above the surface of the water. That's what this stands for. And d is the horizontal distance that the dog travels from the base of the dock, both in feet. So it says determine the horizontal distance of the jump. In other words, how far does this dog go? Obviously, he's starting 2 feet above the water, but we want to find those lovely x-intercepts. And so I'm going to use my regular factoring methods. I'm going to multiply by 10 to get rid of this fraction. I'm going to divide by a negative because that's a nasty one. And then I go ahead and use my decomposition method. Please pause the video and just stop and take a look at this. Make sure you understand how it's going out. When I finally finish, I find out that d is a 5 or a negative 4 over 3. Of course, this makes no sense because we're talking about a dog jumping off a dock. So it appears that the dog traveled a horizontal distance of 5 feet. Lastly, we're going to take a look at this very interesting sport called lacrosse. It says the length of an outdoor lacrosse field is 10 meters less than twice the width. The area of the field is 6,600 square meters. Now, determine the dimensions. This is a classic question. And part of what we need to do is find a way to refer to these things. Do you notice how the length is kind of given to you in terms of the width? And so as I start this question, I'm going to say let W be the width. And if I go back to the text of the question, I can see that the length is 10, sorry, that went on its own. It's 10 less than twice the width. So 2W minus 10. So then I do the area, and it told me in the text of the question it was 6,600. So I go ahead, multiply this out. I've got this lovely quadratic, reduce it by a 2, use my decomposition method over on the side, find that my numbers are negative 60 and 55. So anyway, the width turns out to be a positive 60 or a negative 55. Clearly, distance in our understanding of space and time is not negative. So the width is 60, and if the width is 60, we could use that up here and calculate that our length is 110. Okay, there you have it, solving equations by factoring. Remember, this covers 3 lessons. So your first night's homework was this one, the second night was this one, and the third night was this one. So there's a lot there. Please make sure you go over every single one and come with any questions that you don't understand. Okay, guys, good luck.